The operating system employs various techniques to make it seem as if multiple processes are running at one time. Remember that we said that for the most part, processes don't actually run more than one process at a time, but rather switch between those processes very, very quickly in order to make it seem to the user as if there are more than one process running at a time. And this is generally called multitasking or multiprocessing, and there are different ways that the operating system generally achieves this. So the most basic way, and most of the other ways kind of are based off this way, but is multitasking. And multitasking is really what happens when the processor switches out between processes after a certain amount of time has elapsed. So the scheduler in the operating system will schedule a number of processes to be executed. The resources of the processor will then be handed over to process A, for instance. Process A will then get to use the processor until such time as the system either suspends it because it's used enough time in the processor, or it's waiting for some kind of input, for instance, or it receives an interrupt. So process A will continue to be processed unless, of course, um, an interrupt occurs which takes higher precedence, or it's waiting for input. At that case, it will then switch to process B, or whichever process has created the interrupt. Process B will then get to use the processor until such time as the job is either finished, is interrupted by the CPU, or some kind of other interrupt, or is waiting for I/O, and then the next process will get a chance, etc., etc. So each process really gets a very small amount of time to use the processor before it's interrupted. And because this switching and this changing of processes takes place so quickly, it appears as if the processor is running more than one task simultaneously. Obviously, the operating system is responsible for managing all of this, and that's quite an important part, and we spoke about this earlier with regards to the scheduler in the CPU. So what really is happening in the CPU and the role that the operating system plays is when a process is executed by the CPU, it makes use of all the registers in the CPU and all that program's data that it currently needs to execute a number of instructions is loaded into the CPU. That data obviously needs to be removed from the CPU, or the registers need to be cleared, and the second process's data loaded into those registers when it's ready to execute. Remember, registers are very small memory spaces inside of the CPU. So after a number of cycles, the operating system essentially, whatever process is executing, makes a copy of those of the data in those registers and saves it to RAM, so that when process A resumes after process B, C, and D has used the CPU, that its data can be loaded back in and it can pick up from the point where it left off. So that's the general concept of multitasking. Extended to that is the concept of multi-threading. Now, multi-threading is where more than one task in the same program or piece of software can be carried out at a time. So a perfect example of this is, let's say you're running a web browser and you're listening to music in one tab and surfing the internet in another tab. Let's say, for instance, you have Facebook running and it pops up a notification. Now, each of those tabs will be running in a separate, what is called a thread. Now, a thread is a subpart of a bigger process. So your entire process is your web browser that's running, and all these individual things that are happening, each tab is running in a separate thread. Another way to possibly explain this is if you think of working in a word processor, one of the threads is the auto formatting, so when it auto capitalizes a letter. Another thread would be the spell check. Another thread would be checking the grammar. Another thread would be you actually typing into the Word document. And the important thing there is that threading shares the same memory space as the process. So the process MS Word is allocated a certain amount of primary memory, and from that primary memory, all of the threads can access that processor's primary memory. So it doesn't have memory of its own. It uses the processor's primary memory, processors, not processors. So the process has a certain amount of memory allocated to it, and each thread can access that. And you could see why that would be important. In the case of a word processor, all of them need access to the document that you're typing in order to perform their task. And this works in much the same way as multitasking. It still swaps out kind of in the processor, but multi-threading is much more of an operating system thing than implemented in the CPU. Now, hyperthreading is much more focused on the CPU. So earlier on, we spoke about the fact that whenever a process gets a chance to use the CPU, all of its data is loaded into the registers. Now, if we're loading data into those registers for each process, that means that when another process gets a chance, all of the data in the registers in the CPU needs to be saved to primary memory, and then the new process's data loaded into the CPU's registers. Now, that's called context switching and can take quite a bit of time. So what hyperthreading does is it duplicates the registers on the CPU. So that really saves us time, because if process A stores its data in one set of registers, when it's finished using the CPU, its data can stay in that first set of registers. Process B can then use the second set of registers to store its data. And that's convenient because when process A takes over again, its data is already there. We don't need to fetch it from RAM. And then when process B gets a turn, its data is already there. So it duplicates the registers, which saves time from having to save that stuff to primary memory and retrieve it again. And that's how it improves the performance of the CPU. So what will happen if you have a single core with hyperthreading, your task manager, if you're running Windows, will show you that there are two CPUs. Now, in fact, the operating system thinks there are two CPUs, but there is in fact only one CPU with two sets of registers. But as far as your operating system is concerned, your CPU has it sees two CPUs because there are two sets of registers, and that's how hyperthreading works. You can see a diagram over here. So you can see this is a CPU chip which has registers which are implemented, or hyperthreading implemented, and you can see that there are two sets of registers. There's only one arithmetic logic unit, there's only one cache, there's one control unit. Only the registers are duplicated. So process A will use this set, process B will use this set, and when the CPU changes between process A and B, its data is already there, even though that process A is only able to use the CPU at one time before process B gets to use it. So it's not processing them simultaneously. Okay, it really is just saving the state so that the separate processes' data don't need to be loaded in at a time. On the right hand side, you see something which is physically two processes, and that's called multiprocessing, which you can see is covered kind of below over there. And multiprocessing actually means that the entire architecture of the CPU is duplicated. So there are two ALUs, there may be two sets of cache memory, you will have two control units, and that actually means that you can process two actual separate processes at exactly the same time. So process A can be processed at the same time as process B. And that is only because there are two distinctly separate processes over there. They're physically two separate processes. Now, sometimes they don't have to be two separate chips. In dual core technology or quad core technology, we can actually have two or four separate cores on one CPU chip, but they still duplicate all of the functionality. So it's either multiple chips or it's multi-core technology, but both of those are represented here, whereas this represents hyperthreading. So you can see there multiprocessing supports what we've just been talking about. And you'll note that it says, unlike multitasking, in which only one program is actually being processed at any given moment because the programs all share one CPU. So that's multitasking, whereas multiprocessing is actually two physical CPUs, and instead of the illusion of processes being processed at the same time, it's not an illusion with multiprocessing or multi-core technology. There are actually more than one process being processed at a time. Obviously, for that, you need a processor that supports that, a motherboard that supports that, especially a motherboard that supports that if you have two physically separate chips instead of multi-core technology. Your operating system will need to support it, and your application software to a certain extent. Don't worry too much about symmetric multiprocessing. It's not vitally important to understand that, but you can read through it if you wish. The same with asymmetric multiprocessing.